Hi everyone. Today I am going to solve previous year's questions in potentiometer. If you want clarity in theory, you can go through the link that I provided in the description. ఇప్పుడు మనం first question చూద్దాం. The length of a wire of potentiometer is 100 centimeter and the EMF of its standard cell is E volts. It is employed to measure the EMF of a battery whose internal resistance is 0.5 ohm. The balance point is obtained at L is equal 30 centimeter from the positive end. The EMF of the battery is right. అంటే ఇందులో ఏమి ఇచ్చారు మనకు పొటెన్షియోమీటర్ వైర్ లెంత్ ఇచ్చారు 100 centimeters. Okay, he gave standard cell EMF, he gave battery internal resistance, and he also gave length over which balance is obtained. Okay, he also gave current I in the potentiometer wire. Right, he is asking us to find battery EMF. Right, the potentiometer circuit for this problem can be drawn like this. So let us say AB is potentiometer wire. Right, this is a standard cell. He gave its EMF as E volts. He gave potentiometer wire length 100 centimeter. Yeah. So let us say this is battery EMF E1. And let us say this is battery internal resistance 0.5 ohm that he gave. Right. Let us say the balance point is at 1 on the potentiometer wire. The distance between junction A and 1 is nothing but 30 centimeter. That is nothing but balance length. Right. Yeah. He also gave current in the potentiometer wire as I. Yeah. At balance ఏమవుతుంది మనకు the battery EMF becomes equal to potential difference between junction and the moving contact position 1 at which balance is obtained. Right. E1 is equal to VA1. VA1 becomes equal to I into RA1 from Ohm's law. ఇక్కడ మనం చూడొచ్చు the standard cell is connected across the potentiometer wire AB. Okay, that means the cell EMF becomes equal to potential difference across what is that potentiometer wire AB. So E becomes equal to VAB is equal to I into RAB. So that is the thing. So when we take ratio of equation 1 and 2, what we are going to get? E1 by E is equal to RA1 by RAB. So let us take it as equation 3. Right. Yeah, we know resistance of the wire is given by the expression R is equal to rho L by A. So where rho is its resistivity, L is its length, and A is its area of cross section. That means resistance of wire between A and 1 is given by rho LA1, length of the wire between A and 1, that is 30 centimeter. I'm directly writing. So area of cross section, let us say A dash. As we used A already, I'm using A dash. RAB, resistance of wire between A and B, that is equal to rho LAB. LAB is, you can see, 100 centimeter by A dash. So when we take ratio, what we are going to get? Rho by A dash is common. RA1 by RAB is 30 by 100. So that is the thing. So you can see here RA1 by RAB is 30 by 100. That means E1 by E, which is equal to RA1 by RAB, that is equal to 30 by 100. So when we take E that side, we are going to get 30 by 100. Which option satisfies D? So that is the answer. Next question, Luna. Right. The length of a potentiometer wire is 1200 centimeter and it carries a current of 60 milliamps. For a cell of EMF 5 volts and internal resistance of 20 ohm, the null point on it is found to be at 1000 centimeter. The resistance of whole wire. So he is asking resistance of whole wire. ఇక్కడ ఏమి ఇచ్చారు మనకి? Yeah, potentiometer wire length ఇచ్చారు. Okay. He gave current carried by the potentiometer wire. He also gave cell EMF and its internal resistance. He also gave potential difference, the balance length over what is that? The length over which balance is up. That is 1000 centimeter. He is asking us to find the resistance of whole wire. Right. Yeah, let us say cell EMF as E and current as I0. మనకు బ్యాలెన్స్ దగ్గర ఏమవుతుంది? Cell EMF becomes equal to potential difference across length over which balance is up. So that means E becomes equal to V1000, potential difference across 1000 centimeter, which becomes equal to I0 into R1000 from Ohm's law. Right. Yeah, he gave, that is 5 volts. I naught 60 milliamps, 60 into 10 power minus 3. R1000 is resistance of 1000 centimeter wire. So, right, when we take 10 power minus 3, that's it. It becomes 5000 by 60. Right, so that means 250 by 3 ohm. So that is resistance of 1000 centimeter. But what we need is resistance of whole wire, that is 1200 centimeters. Resistance of 1200 centimeter wire is given by rho L. L is now how much? 1200 centimeter by A dash. Similarly, resistance of 1000 centimeter wire is given by rho L. L is how much? Here 1000 centimeter by A dash. When we take ratio, what we are going to get? Yeah, so here 2 zeros we can cancel. 2 6 the 2 5 the. So R1200 by R1200 is equal to, so 6 by 5 into R1000. What is R1000? We already got. We can substitute directly. So 250 by 3. 3 into the 5 5. 50 into 2 100. So right, which option is satisfying? D. D is the answer. Next question will be. An ideal battery of 4 volts and resistance R are connected in series to the primary circuit of a potentiometer of length 1 meter and resistance 5 ohm. The value of R2 give a potential difference of 5 millivolts across 10 centimeter of potentiometer wires. అంటే ఇక్కడ ఏమి ఇచ్చారు మనకు ప్రైమరీ సర్క్యూట్ బ్యాటరీ వోల్టేజ్ ఇచ్చారు అండ్ ద పొటెన్షియోమీటర్ వైర్ లెంత్ అండ్ ఇట్స్ రెసిస్టెన్స్. Okay, he also gave potential difference across the 10 centimeter wire, right? He is asking us to find series resistance R. So that is the thing. Yeah, the primary circuit for this problem can be drawn like this. So AB is potentiometer wire. So this is primary circuit battery. He gave its voltage as 4 volts. So this is series resistance, that is R. Right. Let us say I naught is the current flowing through the primary circuit. Right. Let us say 1 is a point on the potentiometer wire at 10 centimeter from A. Right. He gave potential difference across 10 centimeter as 5 millivolts. That is the thing. Right. That means potential difference across A and 1, whose separation is 10 centimeter, is also going to be 5 millivolts. That means VA1 is equal to 5 millivolts. But VA1 becomes equal to I naught RA1 from Ohm's law, right? So that means 5 into 10 power minus 3 is equal to I naught. What is I naught? Current in the primary circuit. That is equal to primary circuit battery voltage by total resistance in the primary circuit. Here resistance R and potentiometer wire are connected in series. So that means total resistance becomes R plus potentiometer wire resistance is 5 ohm. R plus 5. RA1. So let us take the equation 1. Right. The resistance of wire between A and 1 is given by rho LA1. So LA1 you can see 10 centimeter by A dash. Similarly, resistance of wire between A and B, potentiometer wire, rho LAB, that is how much? 1 meter, 100 centimeter by A dash. So when we take ratio, what we are going to get? So rho by A dash is common. So 1 0 cancels. So RA1 is equal to 1 by 10th of RAB. What is RAB? He gave 5. So this becomes, right, 5 by 10. So this is equation 2. So let us substitute equation 2 in 1. Right. 5 into 10 power minus 3 is equal to 4 by R plus 5. So RAB, what is that? RA1 we got as 5 by 10. So 5 5 cancels. Yeah. So when we take 10 that side, 10 power minus 2 is equal to 4 by R plus 5. So this can be written as 1 by 100. Yeah, this becomes R plus 5 is equal to 400. So that means R is equal to 395. So which option is satisfying? Yeah, D. So that is the answer. Next question will be. The current in the primary circuit of potentiometer is 0.2 ohms. Thus, 0.2 ohms. The specific resistance and cross section of the potentiometer wire are 4 into 10 power minus 7 ohm meter, 8 into 10 power minus 7 meter square respectively. The potential gradient will be equal to, right? So that means what he gave current in the primary circuit. He gave the specific resistance and area of cross section of the potentiometer. He is asking us to find potential gradient of potentiometer wire. Yeah, the primary circuit for this problem can be drawn like this. So AB is potentiometer wire, E0 is primary circuit, battery, EMF. Let us say R0 is its series resistance. Let us say I0 is the current flowing to the primary circuit, right? Let us say 1 is a point on the potentiometer wire at some position. What is the potential difference between A and 1? VA1, that is equal to I0 into RA1 from Ohm's law, right? So that is equal to I0 into RA1, resistance of the wire between A and 1. So that is equal to rho LA1 by A dash. So when we take LA1 that side, what we are going to get VA1 by LA1 is equal to I0 rho by A dash, right? VA1 by LA1, potential difference across the length of the wire per that length. This is LA1 is that length of the wire is called potential gradient. Let us denote with A. So right, he gave I0 0.2. He gave specific resistance 4 into 10 power minus 7. He gave area of cross section 8 into 10 power minus 7. So what we are getting here 0.1. So 0.1 volt per meter. Which option satisfies? C. So this is the answer. Right. Let us move to next question. A potentiometer wire PQ of 1 meter length is connected to a standard cell E1. Another cell E2 of 1.02 volts is connected with a resistance Rn switch S as shown in figure. With switch S open, the null position is obtained at a distance of 49 cm from Q. Potential gradient in the potentiometer wire is. So that is the thing. Right. Yeah. So that means what he gave, the potentiometer wire is connected to standard cell E1 like this. So what is the wire length? 1 meter means 100 centimeter. In the sub-circuit, a cell E2 of EMF 1.02 is connected with resistance and switch like this. Okay. With switch S open, okay, the null point is obtained at a distance of 49 centimeter from Q. 49 from Q means 51 from P because total is sum is 100 centimeter. Right. మనకు బ్యాలెన్స్ దగ్గర ఏమవుతుంది సబ్ సర్క్యూట్ సెల్ EMF becomes equal to potential difference between P and J. Clear? P and J. So VPJ. So that is equal to, yeah, let us say I0 is the current flowing to the primary circuit. I0 into RPJ. Right. So that means VPJ is equal to I0 into RPJ, resistance of the wire between P and J, rho LPJ by A dash. So when we take LPJ that side, what we are going to get VPJ by LPJ. So this is the one we are going to get. That is equal to I0 rho by A dash. Fine. VPJ by LPJ, potential difference across the length of the wire per that length of the wire. So that is called potential gradient. So that is our objective. So A is equal to VPJ by LPJ. But what is VPJ? You can see from equation 1, E2. So VPJ is E2. Okay. By LPJ. What is E2? He gave 1.02. That means when we remove decimal point, we get 100 in the denominator. LPJ is 51. So 2 by 100, 0.02. Which option satisfies? Yeah. So that is the answer. Right. So today I solved 5 previous years questions. Thank you.